Hello and welcome to Safety Tavern's video on excavation and trenching. Now, before we start, understand, what I tell my people is 18, but the OSHA regulation is actually 20 foot deep. At 20 foot deep, you need a certified engineer or qualified engineer, whatever wording you want to use. You need an engineer to sign off on the way you design that hole. I tell my people when we get to 15 feet deep, you need to give me a call. Like no matter what, like you need to call me. I am the safety competent for my company, and I've got my competent foreman on the job site. I've got competent superintendents that travel around. So we need to all sit down and have a real talk about what we're doing here, because at 15 feet deep, that starts getting crazy. Now this video, we're going to do it a little bit different than the normals. First, we need to understand something. We need to understand where some of the risks are. Now I'm going to incorporate in this video, this is going to be a little bit of a long video, but as it should be, because it's excavations and a lot of people die from excavations. So first we're going to pull in another company's training video, and it's a very good training video, but I'm going to chop it up again because the flow of it doesn't work for what I'm trying to do here. And then we're going to look at some stuff to understand what 800 pounds of force is, because we hear that term 800 pounds of force and okay, so what? But I want you to truly understand what 800 pounds of force is. Then we're going to go into some soil testing. Keep in mind, there are approved methods of soil testing, and then I'll demonstrate the ones that I personally use all the time that I trust. And then there's also the arguments about a certified engineer has come up and tested the soil, and then you as the competent person come up and test the soil. There's an argument that is going to take place about that, and I'll walk you through what OSHA says about that. I hope that you will understand that this is all about employee safety. If there's a cave-in, who's going to get hurt? If there's a cave-in, is it going to destroy the houses next to us? And it's all about preventing all of that. And as long as we're all, and I mean from the employee, the foreman, superintendents, the general contractor, the rental companies, and the safety people, as long as we're all pointed at the safe job, nobody gets hurt, and we damage as minimal property as possible. That's what Safety Tavern cares about. So let's get right into some of those regulations.
Unsafe excavations kill people. Every year, about 400 U.S. workers die in trenches, and 6,400 are seriously injured doing the work we do every day. That's why you need to understand trench hazards and how to prevent cave-ins. OSHA, the Occupational Safety and Health Administration, has a standard on safe trench procedures to protect you on the job. This program is going to teach you how to classify soil, work in protective systems, and spot excavation hazards. An excavation can be wide, like a block of high-rise basement, or one-sided, like a borrow pit. What all excavations have in common is the potential to kill. You see, when we excavate, we know the walls will fail. We just don't know when. In its natural state, soil stays in place, pulled by horizontal and vertical forces. Excavate, and you've disturbed nature. Soil moves downward and inward to heal itself. When soil starts to cave in, cracks cause the bottom third to fall first. If you are working when the walls fail, you can be buried up to your knees before you know it. And if you're buried up to your knees, you can't get out without help. You see, soil is heavy. An average cubic foot of soil weighs 100 to 125 pounds. Some soils weigh up to 145 pounds. With the suction effect, pulling out one buried worker's foot can take 750 pounds of force. Your body's just not built for that. Or suppose you're buried to your chin. Your chest must move 800 pounds of force to get air in and out of your lungs. What happens is suffocation. Your chest can't move in or out, so even if the dirt doesn't get in your mouth or your lungs, you'll die when you can't breathe. There are other ways workers can be killed in excavations. Objects fall in on them. They drown. They're crushed and suffer massive internal injuries. To keep you safe in excavations, OSHA requires soil classification by a competent person and installation of adequate protective systems before you enter the trench. A competent person has enough training to identify excavation hazards and authority to take prompt corrective action. The type of soil determines the selection of safety system. OSHA identifies soil types as stable rock, A, B, or C.
Now we have a problem here, and that is somebody who knew what they were doing was speaking and then gave the presentation to somebody who didn't know what they were doing as far as safety and excavations go. Thus, this slide looks like this. It should be soil classifications are stable rock, type A, type B, and type C. These are all classifications. It should not look like this. It should look like this.
Type A is the most stable class of soil. It is dense, heavy, and resists penetration. If it dries out, it will develop cracks. Clay, silty clay, and hardpan are examples of type A soils. Type B is the next most stable and is made up of soils like silt, sandy loam, medium clay, and unstable dry rock. Type C soil is the least stable. Gravel, loamy sand, soft clay, submerged soil, or unstable rock are all examples of type C material. Actual classification requires a competent person to identify grain size, saturation, cohesiveness, and unconfined compressive strength. Soil falls into 4 basic grain sizes: gravel, sand, silt, and clay. Gravel is the least stable, and clay is the most stable. Basically, if a grain of soil is larger than a pencil lead, it's gravel. Smaller is sand, and your naked eye can't see particles of clay and silt. In general, the bigger the grains, the less stable the soil, and the more careful you need to be. When you're dealing with water and clay or silt, a certain amount of water makes the soil stable, but too much water causes cave-ins. So along with grain size, the amount of water in the soil must be considered. Soil is made up of rock broken into tiny grains separated by voids. Soil voids fill with water or air. Saturation refers to how much water is in the voids. If the voids are completely filled with water, we say the soil is saturated. If the voids are completely filled with air, we say the soil is oven dry. This dried out soil fissures and spalls off the sides of the excavation. Anything in between dry and saturated is referred to by the percent of saturation. Keep in mind, the more saturated the soil, the less stable it is, since soil slumps and shears off faster when it's full of water. That's why we look at the stability of soil, or its cohesion. Soil stability refers to how well grains hold together and is called cohesion. Cohesion predicts how well the walls of a trench will hold together, or how quickly they'll collapse if unsupported. Unconfined compressive strength refers to how soil reacts under pressure. Soils that readily shear off trench walls are more hazardous than those that hang by tensile strength. Unconfined compressive strength is measured as the amount of weight per square foot required to collapse a sample. Soil is tested visually and manually by a competent person. With experience, you can recognize some visual clues. As you come on the site, look at soil particle size. Remember, if it's larger than pencil lead, it's gravel. Gravel can be type B or C. Angular gravel is type B, and round gravel is type C. If the soil particle is the size of a pencil lead, it's sand and type C. If particles are invisible, the soil can be silt and clay, which could be classified type A, B, or C. But remember, no natural soil is made up of all one-size grain, so you'll be working in mixtures. Next, notice if the soil clumps when it's dug. This may indicate it's clay and silt. Cracks in walls and spalling can mean the soil is type B or C. Layered systems in adjacent hazardous areas such as buildings, roads, and vibrating machinery require special consideration and possibly the services of a registered professional engineer to determine soil type. Water standing in the bottom of the trench or seeping through walls automatically makes the soil type C. You now have a rough idea of soil type, but manual tests are required before protection is selected. Sometimes soil samples are sent to a lab for testing. Sometimes they're tested on site. Whatever method is used, soil is always tested as soon as possible once the sample is removed from the ground to preserve its natural moisture. One warning: testers never enter any excavation to test soil. Soil is first dug out and a representative sample is gathered from the spoil pile. Tests include a sedimentation test that shows how much silt and clay is found in sandy materials. For this test, a sandy soil sample, after removing gravel, is placed in a straight-sided jar with about 5 inches of water. The sample is thoroughly mixed and allowed to settle. Sand settles off in 30 seconds, and a sample with 80% sand will be classified type C. The wet shaking test identifies the permeability of the soil. You can see as the sample is shaken, clay resists water movement through it, while water flows freely through sand and less freely through silt. The thread test is used to determine cohesion. For this test, a disturbed sample is rolled out to 1/8 inch diameter and picked up. If a sample holds together for 2 inches, it's considered cohesive. Clay and silt behave similarly until picked up. Silt breaks off before clay does. A ribbon test is a backup for the thread test, since it is unlikely to be affected by one stray piece of gravel. A sample is rolled to 3/4 of an inch in diameter and squeezed between thumb and forefinger into a flat, unbroken ribbon 1/8 to 1/4 inch thick. As it is formed, the ribbon is allowed to fall freely. If the ribbon does not break before several inches are squeezed out, the soil is considered cohesive. When soil type is known, the right protective system is chosen. Basically, employers may choose from sloping and benching or shoring and shielding. Sloping and benching cut the walls of an excavation back at an angle to its floor. The sides of a sloped system are angled cuts, while benching uses one or more steps. The flatter the angle, the greater the protection. The choice of a slope or support system is based on soil classification and the restrictions of the particular excavation site. Type A is the most stable class of soil and holds together when wet. Clay, silty clay, and hardpan are examples of Type A soils. The ratio of slope established for Type A soil is 3/4 to 1. To determine the slope of a 20-foot trench, start at the trench floor. For every vertical foot rise, the wall of the trench must be cut back 3/4 of a foot. The benching system for Type A soil, with a 3/4 to 1 ratio, will have steps 4 feet horizontal and 5 feet vertical. This forms a step system that can be repeated to the top of the excavation. Type B, the next most stable, is made up of soils like silt and sandy loam, medium clay, and unstable dry rock. The ratio of slope for this soil is 1 to 1. Every horizontal foot run must have a vertical foot. Benching in Type B soil at the 1 to 1 ratio means that each step will have a 4-foot horizontal run and a 4-foot vertical rise. This will form a multiple bench system of protection. Only cohesive Type B soils may be benched. Type C soil is the least stable. It is made up of gravel, loamy sand, submerged soil, or unstable rock. Type C soil needs the flattest angle of slope. With a ratio of 1.5 to 1, the wall of the trench must be cut back 1.5 feet for every vertical foot rise. Due to soil instability, Type C soil is not benched. Sloping and benching diagrams are based on good trenching conditions. Factors like weather, traffic vibrations, and pressure from nearby loads, called surcharge, make soil less stable. A sloped or benched excavation should be re-inspected for signs of distress after any increase in such disturbances. Cracking in excavation walls, bulging of material from its bottom, or separation of small clumps from its sides can indicate a potential cave-in. You will be directed to leave the hazardous area, and the slope will be cut back farther. Shoring is designed to prevent cave-ins by supporting walls with vertical shores called uprights. Horizontal members along the sides are wales, and those placed horizontally between trench walls are cross braces. Sheeting is another name for uprights. Butted together, these members are called close sheeting. Shielding is designed to give employees a safe work area by protecting them from collapsing material. Shielding can be either pre-manufactured or job-built under the specifications of a registered professional engineer. Shields used in trenches are called trench boxes or trench shields. These are usually portable steel structures placed in the trench by heavy equipment. In deep excavations, trench boxes can be stacked and attached to each other with stacking lugs. Using steel sheeting to extend the height of a trench box is unsafe because it overstresses the box. The professional engineer who designed the box is not responsible for its safety if the system is misused. Shields are installed in a way that restricts side-to-side and other hazardous movement. No one is allowed in the shield while it is being raised or lowered into place. Shielding or sheeting used with sloping must extend at least 18 inches above the bottom of the sloped part of the excavation. When using shores or shields, tabulated data provided by the manufacturer or a professional engineer must be followed regardless of soil classification. Any deviation must be approved in writing by the manufacturer. Installation and removal of a support system are safest when done from outside the trench. Individual shores are installed and released slowly to prevent failure of the remaining protection. Excavations must be backfilled immediately after support systems are removed. Occasionally, an excavation is subject to hazardous atmosphere. This can occur when digging near a landfill, in a sewer, or other toxic site. Air will be tested to ensure that it is made up of at least 19.5% oxygen and not more than 23.5% oxygen. Explosive, flammable, poisonous, corrosive, oxidizing, irritating, oxygen deficient, toxic, or otherwise harmful atmosphere will be tested and controlled before you enter the trench. Ventilation and use of personal protective equipment are two means of controlling hazardous trench air for your safety. Underground utilities are located and marked by the appropriate gas, electric, or other company before excavation starts. Excavated material and other objects must be kept at least 2 feet from the opening. No one works on the sides of sloped or benched excavations above other employees unless the lower worker is protected from falling material. No one is allowed underneath loads handled by lifting or digging equipment. No one except the operator is to be close to a vehicle being loaded or unloaded. Barricade tape draws attention to the work zone, but does not serve as a physical barrier to keep people and vehicles out. Trenches 4 feet deep or more must have a safe means of exit, such as a ramp or ladder, within 25 feet of every worker. Hard hats are required in any work zone, and vests are required when working in a street. Any excavating under the base or footing of a foundation or wall requires a support system designed by a registered professional engineer. A top person who observes trench work from outside the excavation can detect moving ground and warn workers to leave the trench until hazards are controlled. Before you go to work in an excavation, know what you're getting into. It can be done safely if you know about soil classification, protective systems, and conditions that can weaken the protection. It's up to you to work safe.
800 pounds of force.
Try another shot or not? Oh, it's gonna be a nice. Yeah, y'all my little.
800 pounds of force. It's a serious thing, and it happens with just a little bit of dirt on your chest. Now, the previous video got into soil classifications, but I think we can do just a little bit better. Let's revisit soil classifications.
Soils can be classified as Type A, Type B, or Type C. Type A soil is the most stable soil in which to excavate. Type C is the least stable soil. It's important to remember that a trench can be cut through more than one type of soil.
The original video that I got this from, the sound disconnected from it when it copied over. Nothing I can do about that. But the video itself shows some great representations of how I actually do soil testing. let's take a look at thumb penetration test. I really do this exact test. You take you a clump of soil and you push your thumb into it. Keep in mind that they're shake. Like, see, look how hard he's shaking right here. Put some serious pressure behind this. Now that was type A. Type B, as he pushes in, it's going to receive him pretty much up to about the fingernail. If you can still see the fingernail, it's something between A, B. If you can't see the fingernail, you're looking more like B. And if you get to the knuckle, you're looking something more like C. Again, a quick recap. A, you can definitely see the fingernail. B, fingernail's starting to disappear. And C is up to the knuckle. Now, the next test that I always do is plasticity test. The way we're going to do this is you're going to take a clump of the soil and you're going to roly-poly it up. I call it the roly-poly test. You're going to roll it until you have roughly 2 inches by 1/8 of an inch. Hold it upside down, make sure it doesn't break. The OSHA regulations that are being referred to here is 1926 subpart P appendix A delta 2I and delta 2 triple I. I am not going to read all this out, but you're more than welcome to take a picture right now. People, this is not the place you want to play around. There have been people that have been crushed in excavations over and over. And I hate to say this, but I promise you, whatever year it is, right now it's 2021, but whatever year you're watching this video in, somebody this year is in America is going to die from an excavation collapse. And it's 100% preventable. We know how to dig in the dirt. We were literally digging in the dirt as children at the beach. We know how to dig in the dirt. Yet, when we get older, we act like, oh, physics doesn't exist anymore. This is basic physics, people. This is gravity. There's no justification. There's no logical reason. This isn't, I was wearing my safety glasses and sand blew behind and hit the thing and got in my eye. This isn't one of those fluke injuries of, man, I just tweaked my knee. When people get hurt from excavation cave-in, it is 100% preventable. 100. Dude, I've had to tunnel under a building. And the building was like 80 years old. So this thing was like really decrepit and dilapidating. And we tunneled under that building just fine. We were very cautious and worried about everything we were doing. We quadruple checked everything. But we can do this. We know how to dig in the dirt. The question is, are you, as a supervisor, are you going to put your employees' safety over the budget and your time restraints? What's going to be the most important thing to you? Making sure everybody goes home to play with their kids tonight, or making money? You tell me, because that's what it all boils down to. If I take every one of these fatalities and I drag that supervisor in, I'd be willing to bet at some point he either refused to go to training to learn to do it the right way, or he bypassed his training. That's it. Those are the two choices. Or it was a mom and pop company and they had no clue what they were doing and they probably shouldn't have been doing construction anyways. I'll take that. But one way or the other, there's no excuse for anyone getting hurt from a cave-in. There's just not. We know how to dig in the dirt. Now, there is another test called a penetrometer, and you can buy these at Grainger or wherever. And you take a device that looks like this and you press it into your sample. My problem with this is you can't tell if you're hitting a rock or not. That's why I like to use my hands. I never teach the penetrometer test, ever, because the possibility of false readings. Now, I'm sure some of y'all think that we're just being a little bit too hard, but if you take a look at this next video, you're going to understand exactly why we go so hard on this kind of stuff.
Who's in charge today? Huh? Who's in charge today? How you doing? I'm in the state of Oregon, Oregon OSHA. Looks like you got a little bit of a shoring problem going on.
That's it. That's what we're installing right now.
Well, he can't be down there.
Okay.
How are you going to get him out?
Shoring or what? Jim, just unhook that thing. Sorry. Watch it.
You want to see why he can't be down there?
What?
That's why he can't be down there.
Okay, it's still sheets you gotta go in.
Okay, you got to get him out.
Let's go overseas. In this excavation, they've already had a cave-in. These are rescue workers. I'm not sure why the military's here, but okay. But they've already had a cave-in, and they're trying to rescue somebody. Let's see what happens. So let's take a look at some of the things that just might prevent all of these cave-ins. 1926-651 Kilo 1, daily inspections of excavations, the adjacent areas, and protective systems shall be made by a competent person for evidence of a situation that could result in possible cave-ins, indications of failures of protective systems, hazardous atmospheres, or other hazardous conditions. An inspection shall be conducted by the competent person prior to the start of work and as needed throughout the shift. Inspection shall also be made after every rainstorm or other hazard increasing occurrence. These inspections are only required when employee exposure can be reasonably anticipated. 1926-651 Bravo 1. The estimated location of utility installations such as sewer, telephone, fuel, electric, water lines, or any other underground installations that reasonably may be expected to be encountered during excavation work shall be determined prior to opening an excavation. Shall be determined prior. 1926-651 Bravo 2. Utility companies or owners shall be contacted within established or customary local response times, advised of the proposed work, and asked to establish the location of utility underground installations prior to the start of actual excavation. When utility companies or owners cannot respond to a request to locate underground utility installations within 24 hours, unless a longer period is required by state or local law, or cannot establish the exact location of these installations, the employer may proceed, provided the employer does so with caution and provided detection equipment or other acceptable means to locate utility installations are used. Now, upon reading this, most people are going to turn around and say, oh, well, we just call 811. Well, you have a massive problem. 811 only tells us what the utility companies puts in the ground. It does not tell us what the customer put in the ground, nor the shady people that the customer may have hired in the past 1, 5, 10, 25, 50 years. What has the customer put in the ground? Because the utility companies and 811 are not going to be able to tell you that. So how do we keep from hitting lines? First, we call 811 dig, make sure there's no public utilities in the area. Then we ask the customer, can we have the drawings? Can we have the blueprints? Can we have everything that's in the ground right here? If there's any questions, do not just dig. This is how this happens. This is how these kinds of things happen. Do not just dig. If they know what's in the ground, good to go. But if there's any reason for us to think that these blueprints, drawings, or whatever the customer gave us is incorrect, this is what can happen if the customer doesn't know exactly what is in the ground. Do not risk your employees' safety. Do not risk your safety over the customer not knowing what they're doing. There are other options like hydro digging or soft digging. There are other options. Do not just take your backhoe and dig it into the ground. 1926-651 I-2. Everything you pull out of the excavation, all the spoils, has to be at least 2 feet away from the edge of the excavation. This also includes any kind of materials or heavy equipment or anything else. Anything that could possibly fall in or roll into the excavation must be 2 feet away at a minimum. 1926-651 Hotel 1. Employees shall not work in excavations in which there is accumulated water, or in excavations in which water is accumulating, unless adequate precautions have been taken to protect employees against the hazards posed by water accumulation. And 1926-651 Charlie 2. Means of egress from trench excavations, a stairway, ladder, ramp, or other safe means of egress shall be located in a trench excavation that is 4 feet or more in depth, so as to require no more than 25 foot of lateral travel for employees. Do y'all like playing games? I like playing games. Come on, let's play a game. What we're going to do is I'm going to show you a picture and you're going to identify as many unsafe acts as you possibly can in this picture. Y'all ready? Here we go. The first screaming issue is, why are we doing lifting ops when right here there's a guy not even looking at us, not even paying attention? The second issue is this a confined space right here? Are there people down there? What is going on with this entire picture? This is way too cluttered. We need to clear out this person, clear out the confined space equipment, maybe put something over the hole to where we're not literally almost falling in as we're manipulating this trench box. Then we can look at landing this trench box. Holy rusted metal, Batman. Could you imagine you're working right here, there's an emergency, right? So you scamper up your ladder, you get what is that, 12 feet up in the air? And now you have to do what? Jump down another 8 feet into who knows what? Or I guess you can jump onto the fence here and cling on for dear life. What is that, an 8-foot, 6-foot fence? This is not a safe landing. You're literally escaping potential death down in this excavation just to have to deal with impalements. And no, this is not how we set up excavation access and egress. This is not acceptable. First and foremost, there's no shoring, there's no sloping, there's no benching, there's absolutely no protective systems. Boom, immediately shut them down. Number 2, that employee is way too close to that piece of equipment being up there. Next, what are these guys doing? Why are they just looking down the trench? That's literally more than a 6-foot fall. Get out of here. Other one, right here, this is caution tape. Is this a caution tape situation or a danger tape situation? Again, go back and look at signal signs and barricades if you want to know which one needs to be used, but I can tell you that needs to be red. That needs to be danger tape. Absolutely unacceptable. Every now and again, my job is pretty easy, and this is one of those situations where a picture tells 1,000 words. This was like Thursday when OSHA shut this job site down, and this was Monday. You see, this is called a cave-in. This is a shear wall, and this is what it looks like when a shear wall caves in. Do not work near shear walls ever. Here we go again. We're in an excavation. This looks very much like Class C soil. Very fine grained, very dried out. Now, I take Class C soil, I stick a 6-foot male in here, and he is clearly over his head. Boom. Employee gets out of the hole immediately, and both these people need disciplinary action. This is insanity to its max. The next issue, are they having their soils 2 feet away? Not even a little bit. I'm actually a little bit uncomfortable with how close he is to that operator's boom. If that operator is pulling back to dig some dirt and he just has the slightest bit of an issue, a mess up, he could smack that employee, and that's unacceptable. For me, I have my employees move all the way back to where there's no way the operator's boom can come into contact with the employee. Before I let my employees approach, as if they're undoing a bundle of master pipe or something like that, before my employees approach the boom, I tell my people, make sure that operator shows you his hands and tucks them in his armpits. He does, or turns the machine off. He does not go anywhere near the controls while you are going up to unhook something. At all, ever. I've seen it where a Mini X operator pulled back on a bucket when he was doing a bucket change and snapped somebody's finger off. Do not let the operator have his hands on the controls while you, the employee, are near that boom. Ever. Not even once. Not for a second. I don't care how long you knew the guy. I don't care if you're drinking buddies. Never, ever, ever. Got us a pretty easy one right here. Are you allowed to be in an excavation that has standing water? The answer is no. No. He can absolutely clean all that water out from outside of the excavation. There's no reason to be in that excavation with standing water. Get out of the excavation. And finally, we have table B1 from OSHA 1926. We're looking at the maximum allowable slope. So type A, type B, and type C soils. This is how you can slope them. This is how you can slope them. It's a 1-to-1 ratio for type B, and it's a 1.5-to-1 ratio for type C for sloping. This class is not at all intended to be an excavation competent person class. This is an employee entering an excavation that their competent person for their company, job site, has signed off on, and they're entering in. This is intended to be employee entry training. That way the employee, and again, well, that's why we talked about the soil types, is that way the employee, if they see something that they believe is an unsafe situation, they can immediately protect themselves, get out of the excavation, and notify the competent person. This is intended for employees. I promise you, there's a safe way to do it. Please take care of your people. Please. I hope this video finds you well. I hope you use what you learned. And I'll see you in the next video.